Hello, welcome to Advanced Composites. Today is the last day of the ongoing week, which is the 10th week of this course. And today we will continue our discussions which we started yesterday, that was about free vibrations in rectangular composite plates. Specifically, we had developed a governing equation which dictates the vibrational behavior of these plates, and using that governing equation we had computed natural frequencies and associated modes for a rectangular composite plate which was simply supported on all four sides. The plate which we considered was symmetrically laminated, and also each of its layer was orthotropic in nature, so that the D16 and D26 terms for the plate were 0. So, for such a plate the natural frequency was computed as dictated by this relation. Now, let us see how this compares to isotropic plates. So, again we will consider a plate which is isotropic, rectangular in shape and simply supported on all four sides. So, for an isotropic plate which is H thick, Q11 for such a plate is same as Q22, and that is equal to E over 1 minus mu square. This is something which we have already discussed in one of our lectures, earlier lectures. Also, Q12 for such a plate is E times mu divided by 1 minus square of Poisson ratio, and Q66 is equal to G, and that is same as E divided by 2 into 1 plus Poisson ratio. So, if the plate is H thick and that is my Z is equal to 0 plane, mid plane, then for such a plate D11 will be same as D22, and that will equal Q11 divided by, so Q11 times minus H by 2 to H by 2 Z square dz, and that gives us E H cube over 12 into 1 minus mu square. Okay. So, this entire term I call it D. Similar D12, so D12 is same thing, but instead of Q11 or Q22 I replace this by Q12, so it is same as D times mu. And D66 is equal to E over 2 into 1 plus mu into minus H over 2 to H over 2 Z square dz. So, this is equal to so it will be E h cube over 24 times 1 plus mu. Okay. So, let us find out the sum of D12 plus 2 D66. So, this is equal to E h cube. So, what is D12 E h cube times mu divided by 1 minus mu square plus 2 times d66. So, it is 2 E h cube over 24 into 1 plus mu. Okay. So, this becomes E h cube and this is nu minus 1 minus nu square. So, there is a 12 here. So, there is a 12 here plus 1 over 1 plus nu. Okay. So, you add these up and what you get is ultimately E h cube by 12 into 1 minus nu square. So, this is same as d. Okay. So, d12 plus 2 d6 is same as d, and d we have defined earlier, which is E h cube divided by 12 into 1 minus mu square. So, we plug this relation and this relation back into our equation for the composite plate. So, what we end up getting is omega mn is equal to pi square over b square r square times square root of d over rho times m4 plus 2 m square n square r square plus n4 r4. This is what we get, and this thing is nothing but m square plus n square r square, the whole thing squared. If I square, so this is, so the square root of this is m square plus n square r square. So, this is equal to pi square divided by b square r square times d over rho times m square plus n square r square. That is there. So, these are the natural frequencies, angular frequencies, natural angular frequencies for isotropic plate. Okay. Now, what we will do is we will make some comparisons and see what it tells us. But before we do that, very quickly we will see that what is the first natural frequency. So, omega 1 first natural angular frequency for this case will be pi square over b square r square times d over rho and times m square is 1 plus r square. So, this is the first natural angular frequency. So, next thing is what we are going to do is we will compare the results from isotropic plates as well as from composites. Okay. So, if we have to do that comparison, we will make some assumptions for orthotropic plate. We have already developed the relation, but we also need some numbers. So, we will say d11 over d22 is 10. What does that mean? That in the two direction the plate is very easy to bend, in the one direction it is very stiff. Okay. And the other thing we will say is d12 plus 2 d66 divided by d22 is 1. So, this is for orthotropic plate, and for isotropic plate we already know that d11 over d22 is 1 and it is same as d12 plus 2 d66 divided by d22. This we have already shown, so we do not have to worry about it. But both these cases we will evaluate assuming that the plate is square, so R is 1. Okay. So, let us construct a table. So, before we construct a table, we will simplify these relations. So, omega mn for composite with these simplifications. So, if I put these ratios back in this expression, where is that? In this expression. So, d11 I say as d11, this thing it becomes d22, right, and this is also d22, and this is 10 times d11 d22. So, this is 10 d22. So, we are taking a material which is whose d11 is 10 times d22, this twice of d12 plus 2 d66 d22, and so on and so forth. Okay. And R is 1, R is 1. So, if we do that, this entire expression simplifies to pi square over b square, R was 1 times 10 d22 m4 plus d22 n square m square plus d22 n4, and then of course there is a density in the denominator. So, I take d22 out. So, omega mn, when I normalize it, I divide both sides by pi square, and this d22 comes out, rho over d22, okay, and into b square. So, this becomes just 10 m4 plus n square m square plus n4, this thing, and there is a 2 here. So, there is a 2 here because d12 plus 2 d66 is divided by d22 is 1, and this entire factor gets multiplied by 2. So, there is a 2 here. Okay. So, let us construct a table. So, this is omega mn, and this is omega, this entire thing is normalized with respect to some constant which is b, rho, d22 and pi square. Okay. So, m n, and let us call this f mn. So, this is not frequency, but some normalized frequency. Okay. So, we will calculate the value of this normalized frequency. So, my aim here is to find out those combinations of m and n such that f m n is least. So, I want to first find out the first 4 such values, which are minimum. So, when will it be minimum? When m is 1 and n is 1, that is the first thing. So, when m is 1 and n is 1, then this is 10 plus 2 12 plus 1 13, square root of 13. So, square root of 13 is 3.61. Okay. What is the next one? If m is 1 and n is 2, then this becomes, first term becomes 10, second term becomes 4, 8, third term becomes 16. So, 8 and 16 24 plus 10 34. So, square root of 34 5.86. If I take any other value of m and n, it will be more than this. So, this is the one which I take. Then the third lowest f m n is for this combination, m is equal to 1 and n is equal to 3, and this value comes to be 10.44, and the fourth one is 2 and 1, and this comes to 13. Okay. So, this is there. Now, what is the mode shape? So, mode shape will be sin pi x over a sine pi y over b, right, and a and b are same in this case. Here it will be sine pi x times 2, no, sine pi x over a sine 2 pi y over a, because a is same as b, and this is here is, so these are the mode shape, and this is sine pi x over a sine 3 pi y over b, and this is sine 2 pi x over a sine pi y over b. So, if I have to see what are, so if I plate, so let us make, so these are four, this is a square plate. So, if I have the first mode, if this is active, then x will be 0 on this line and x will be 0 on this line, because when, so this is suppose x axis and this is y axis, then x will be 0 at x is equal to 0 and x will be 0 at x is equal to a. Okay. This is the first mode, and of course, it will also be 0 on the edges. So, this is the first case, this is second case, this is third case, this is fourth case. So, the plate will vibrate in such a way that all the 4 edges are fixed and the middle of the plate will do this, but edges will remain fixed. Now, let us look at the second mode. Second mode tells us that it is sine pi x over a times sine 2 pi y over a, right, which means, so b is same as a because aspect ratio is a is equal to b. Okay. So, you can call it a or b, it does not matter, these are rectangular plates. Okay. So, again here the plates, of course, the outside edges will be fixed, and because this is 2 pi y over a, it will also be fixed in at the middle line. Okay. Because aspect ratio is 1. Yes, we had mentioned that aspect ratio is 1, r is equal to 1. Okay. So, what does this mean? That if this is the x axis, so the first frequency we have already talked, the second frequency will be such that if this is the x axis and this is the y axis, then the second mode will be such that the plate will tend to do like this also, like this, and of course, it will do this, but it will also, it will do this thing. Okay. Then the third mode is this guy. So, here all the 4 edges are of course going to be fixed and the node lines for 0 displacement for W will be here also. So, this is second and this is third, and in the fourth case outside edges again are going to be fixed, but an additional node line will be in the vertical. So, this is the fourth mode. So, this is how this plate is going to vibrate. Now, let us look at isotropic plate. So, in isotropic plate, if r is 1, then omega mn is equal to pi square over b square times d over rho times m square plus n square, that is all, okay, because r is 1. So, if we plot this m square plus n square, if we create a table, so m n f m n, and let us look at the first 4 modes. So, this is 1 1 2, 1, 2, 5, 2, 1, 5 and 2, 2, 8. So, how do the modes look in this case? So, we will draw it. So, these are the 4 cases. In the first case, the fixed boundaries are all the 4 edges are fixed and those are the only node lines. This is case 1. In the second case, I have one half wave in the x direction. So, this is again x direction and this is y direction, one half wave in the x direction and 2 half waves in the y direction, and of course, all the edges are fixed. So, it is like this. This is case 2. In case 3, it is the same shape, but rotated 90 degrees. So, this is 3, and in case 4, the plate will have 2 half waves in x direction and 2 half waves in y direction. So, it will be like this. Okay. So, the point is that even though the geometry of the plate is same, they will vibrate with different mode shapes and at different frequencies, because in isotropic plate the plate is equally stiff in x and y direction, but this plate is very soft in the y direction. So, it tends to bend more easily in the y direction. So, it develops more half waves in the y direction early on, and those are lesser modes. So, this is what I wanted to capture and it provide you some glimpse into how plates vibrate when they are made up of composites, and their vibration patterns could be fundamentally different than the patterns seen in isotropic plates. So, that concludes our discussion for this week, and we look forward to seeing you on Monday, which is the coming Monday. Thank you. Bye.